let's learn about the Bohr model. So before we just get into the Bohr model, let's learn about, or let's make sure you know about, you should already know this, the periodic table of elements. So let's just review, make sure you know all of this. So I'm just going to use oxygen as my example here. So oxygen, right here you have your symbol, and let me just zoom in so you can see. So here you have your symbol. Right here is your mass, is your atomic number, and here is your mass number. So your mass number, as you can see, is kind of a rough number here, and for most of your elements it is. But you can really just round it to the nearest whole number, which is what you usually do. There's no point in not having a whole number. So just round it to your nearest whole number. Okay, and now let's learn about the relationship between protons, neutrons, and electrons. So first, protons. So what are protons? Well, protons are the positively charged particles that are inside the nucleus of your atom. So the protons are the same as your atomic number. Sorry, I don't know, I keep saying mass number. So yeah, it's the same as your atomic number. So for oxygen, it's 8. So it's the same as your mass number. Oh my god, I'm so sorry. Okay, atomic number. So the same as your atomic number. So it's exactly your atomic number. So here's 8. 8's your atomic number. That's how many protons you have for oxygen. So we're just going to write in same Then what about electrons? Well, electrons are also so easy. It is also the atomic number, or if you already have your protons, that's the same thing because your protons are also. And the reason why is because in a neutral atom. So what this means is a neutral atom is an atom with a nor positive or negative charge. So if you're doing ionic bonding, you'll probably only have neutral atoms. And so yeah, but you'll probably know if you don't have neutral atoms. That's a little bit more advanced. But anyway, so electrons are in the outside layers of your atom. So they make up most of the volume of the atom, but your nucleus is where all the mass is. So they have to equal out the protons. This is why it's the same. This is why they're the same. So this is the So that should make sense. And what about the neutrons? So neutrons are just neutrally charged particles also in the nucleus. So, but how do you find the neutrons? Well, this is a little bit more complicated. So for the neutrons, you're going to need your mass number. So again, let's just take oxygen as an example here. So for oxygen, you're going to have your, oh, it doesn't let me highlight. Okay, anyway, you're going to have your atomic number and then your mass number here. So you're just going to subtract your atomic number from your mass number, which you're going to make sure to round. So right here it's 15.999. It's going to round up to 16. Again, I'm just picking on oxygen, but it really can be anything else. So, okay, Okay, anyway, so yes, so your neutrons is going to be your mass number. This is your So you're going to be subtracting the atomic number from the mass number because typically the mass number will be bigger. I think it'll actually always be bigger. You'll learn about why later. So mass number minus atomic number. This is so that's your neutrons. So let's do a quick example and hopefully it makes sense. So let's use lithium. So lithium we have right here at the beginning of our periodic table. So lithium has a atomic number. Lithium has an atomic number of 3, the 3 right here, and a mass number of 6.941. So basically you're going to round this up to 7. But first, let's just find our number of protons. So first, how many protons do we have? Well, if we have 3 as our atomic number, then that is your number of protons. So protons is just going to be 3. Then what about, let's go electrons. Well, this is really easy. You don't even need to look at your periodic table again because you know it's your atomic number or number of protons because it needs to cancel out to make in a neutral atom, which we're dealing with a neutral form of lithium right now. So it's going to be 3. So 3 is our number of protons. So it's going to be 3 electrons. Now, what about neutrons? These are slightly more complicated. Well, we have our mass number here of 7, which we're going to round up to 7, and then an atomic number of 3. So all we're going to do is just 7 minus 3 is 4. That's our neutrons. Our neutrons is 4. There are 4 neutrons in a neutral lithium. So neutrons, there are 4 of them. Alright, now let's learn about the model itself. So the Bohr model was invented by Niels Bohr, and it is really a small model of the atom, atomic structure. So, okay, now I'm going to show you an example which will hopefully help you learn about what the model is, because you know all the information that is needed for it. So let's just use something like oxygen for our example, since we already know oh so well about it. So oxygen, so let's just find our properties or our number of neutrons, protons, and electrons for oxygen first. So this is how you set up your Bohr model. You're gonna have your symbol here, which is gonna be, in this case, oxygen O for oxygen, and now you need your number of protons and neutrons. So what is your number of protons? What you know your atomic number here is 8, so you're just going to have 8 protons. And now what about neutrons? So let's find our neutrons here. So we have 16. We have 16 here as our mass number and 8 as our atomic number. So what do we need to do? Well, that's pretty easy. 16 minus 8 is just 8, which means we also have just 8 neutrons. So, and now we draw a circle around this. Why? Because this is our nucleus. So here's our nucleus, but of our atom. So in the atom, the nucleus is responsible for holding most of the atom's mass. And now, what's next? Now we need what's next in the atom? Electrons. This is the electron cloud, which is going to be the cloud of electrons outside the atom, which is responsible for more of the volume of the atom. So how many electrons do we have? Well, if we have 8 protons right here, if we have 8 protons, how many electrons are we going to have? we are going to have 8 electrons. So 8 negatively charged electrons. So in our first ring here, this is where we're going to put our electrons, except this ring holds only 2 electrons. So these are your innermost electrons. 1, 2. That's it. That's your innermost electrons. They hold 2. Your innermost energy level or shell of your atom in your electron cloud, it holds 2 electrons in the Bohr model. So first shell holds only 2 electrons. This is a sign for electrons in chemistry. So, okay. Now, let's get on to our other electrons. As you know, we have 8 electrons, but we only have 2 in here. So, it means we have 6 left. So, let's write those other 6, except we can't put them in this shell because this shell only holds 2. So, we need another shell, that means. So, let's draw this. Oh, no. Okay, sorry about that. Let's see if we can get a nice circle. Yes, there we go. Okay, so this shell holds, so any shell after the first shell, you know, for your really big atoms, you're going to have like many shells. They all hold 8 electrons after your first shell. So every shell holds 8 electrons. 8 electrons after the first shell. So we don't have 8 electrons actually here. But we do have 6 because we already wrote 2. So let's write those 6 in. Yeah, if you want, try and make them look a little bit symmetrical. Now, let's just circle them here real quick so you can see them well. Okay, so yeah, those are our electrons, except here's something extremely important, and make sure you remember this, but it is not hard. This, in oxygen, in the Bohr model, is our outermost shell, because there's no other electron shell in the electron cloud after this shell. And it holds 6 electrons. This means every electron in this shell is a valence electron. So they are all valence. They are valence electrons. So this is not hard. Just remember, trust me, it'll really help when you get into bonding. Every atom here, every electron here in this outermost shell are valence electrons. This will really help you. So that's it. That's the Bohr model. Let's do one more example. Make sure you know it well. So let's just do an atom we've also already looked at here, like lithium. Lithium is usually in smaller batteries now. There's some lithium. It's usually where you know about lithium in real life. Okay, so let's draw a Bohr model on lithium. So let's look at lithium real quick. So we can see lithium has 3 as its atomic mass number. So 3 is the atomic mass number, which means so first thing actually we want to do is write our symbol, Li for lithium. And since 3 is our atomic number, that is 3 protons. Then let's find our neutrons, our number of neutrons. So for this, we need our mass number, which here we can it's 6.9 941, we can just round up to 7. So that's 7 minus 3. So 7 minus 3 is obviously 4. So 4 neutrons. Now, what about electrons? Well, first let's draw our first shell. Okay, now we need electrons. Well, we know here we have 3 protons. That means we have 3 electrons. So let's just draw 2 in, because we already have our first energy shell. It's closing in our nucleus. Now, how many do we have left? Well, we have 1 electron left in lithium. So let's make our second shell here. And we have to just put just 1 electron here. And they're very important. And it's going to be a little quiz. What is this electron called? Hopefully you know this, guys. Please know this. This is very important. I guarantee it'll help you later. This electron is called the valence electron in the outermost shell. So the electron in the outermost shell is a valence electron. This is really important. Even what we're going to be doing in like the next chemistry video will be all about valence electrons, because this really is what bonding is and what we will be learning about soon on this channel. So let's do a quick review now to make sure you know this all. So today we learned about the Bohr model. So we did a quick refresh on the periodic table, and then we learned about the relationship between protons, neutrons, and electrons. So we know protons are the same as the atomic number, our number up here. Electrons, that's the same as our protons, or the atomic number. Neutrons, these are a little bit more complicated. So this is just your mass number, which is a number down here. So you're going to subtract your atomic number, which is your number up here, so we already know. You're going to subtract the atomic number from the mass number, which you're going to make sure to round up to the nearest whole number, or down. And that gives you the number of neutrons. And then we did a quick example. You can always replay this part of the video so you make sure you know it well. Then we learned about the Bohr model itself. So we learned that inside of the Bohr model, you put the symbol, number of protons and neutrons, and on the outside, just like in a real atom, except in a real atom, the distance would be a lot farther if, let's say, a proton was, or if the nucleus was really this big. This is a cool fact. So if the nucleus of an atom was about the size of your fist, the atom wouldn't be in the same room as you. So it would be very far, even if you're in a very big room. In fact, it'd be like a few kilometers or more away. That is very far. So it kind of shows you how much volume the electrons really add to the atom, but also how small atoms are. Okay, so back to the Bohr model. We know here is our first shell where we write 2, where that can fit only two electrons, and then our next shell, which can fit up to 8. We didn't need to fit 8, but there can be many shells after for your bigger elements, and those all fit 8. Just the very first one fits 2, everything else fits 8. And then, very important, your outermost shell holds the electrons in your outermost shell are valence electrons. So they're your outermost electrons. This is very important, guys. Please know it. Then we also did another example here. You can always just replay that part of the video and make sure you know it well. Okay.